This video will go over the Trend Edge Width tool, which is the generic tool name under the function list. This tool is used to detect multiple width measurements, which is a distance between two edges, across a selected area of the target. It is useful to detect the maximum and minimum widths of a target with one tool and determine if they are within the desired specifications. The Trend Edge Width tool can also be found under the Dimensions Geometry category under the Measure Width subcategory. It is the same tool function, just optimized for certain types of measurements. The first one is Width Max Min. This is optimized to measure the maximum and minimum width of a target in a linear direction like the X and Y dimension, like the width of extruded rubber or other target. Diameter Max Min is optimized to perform width measurements on a circular type target, like diameters of a washer or other round target. And Peak to Peak Width is set up to not only measure the min and max width of a target, but also the outermost diameter from all the detected edge points and the innermost diameter of all the detected edge points. This is useful when measuring diameters on a threaded part like a plastic bottle top. We'll show an example of each type of these measurements. Our first example will use the Width Max Min, which is just simply the Trend Edge Width tool, and will measure min and max diameter in a linear direction. The very first step with any tool setup will be to register the image. What that will do is store a reference image in the program settings, and you can work off that image when setting up the tool. We've already done that, so you can see our reference image is currently being displayed. So now we will go ahead and set up our inspection region. Now when you choose this tool from the Dimensions Geometry category under Width, your only choices will be rectangle or rotated rectangle, since this is geared for a linear type measurement. In our example here, we're going to profile the width of this target going down the center and make sure the width remains constant across the whole entire region. This could be like an extruded rubber hose or other part that's just needs to be consistent in width across the region here. So what I'll do is go ahead and set this rectangle right about there. So what we'll do is we'll scan from top to bottom and measure the diameter across that whole region. Just click OK when the region has been set, and you can move on to the next settings. The next step then is to set up the detection conditions for the Trend Edge Width tool. So one of these settings is called the mode. You need to select which mode you're going to use. Now, when you're using a rectangular type rectangle or rotated rectangle inspection region, the mode will be either outer gap or inner gap. And this really only makes a difference if you have more than two edges. In our example, we only have two edges, so that's the only edges we have to work with. But if you had a part that had more than two edges, like a part that was hollow, where it had at least four edges, you can choose to measure the outermost distance, which would be the distance between the outer two most edges, or you can change this to inner gap, and what will be is kind of an inner diameter, if you will, or inner gap, so the distance between the inner two most edges. In our example, like I said, we have two edges, so it doesn't really matter, but we'll go ahead and leave it an outer gap. Now the trend direction is the next setting here, which is already set up the way we want it, but it's the way it will break up the region into many smaller segments and perform those edge width measurements. So right now it's set for top to bottom, but you could also choose left to right. But top to bottom is what we want, so what it'll do is it'll start at the top, perform break it into a segment here, shift down by a certain amount, perform another segment measurement here, and so on. So it'll perform a bunch of edge measurements or edge width measurements starting from the top and working its way down. You can see that's indicated by these yellow points here. Each one of these pairs of yellow points here is an edge width reading, so it's performing many edge widths all in one. In this setup, we have some nice clean edge points to work with, so we don't really need to adjust anything. But in the actual setup, if you need to, you can adjust all the detailed edge detection condition settings like scan direction, edge direction, etc. You can also adjust all the detailed segment conditions like segment size and segment shift. We're going to leave these the default setting, but if you needed to detect finer details, you can change the size and shift and max segments accordingly. You can also go into the detailed detection conditions here, and one setting that's unique to the Trend Edge Width tool is called Lower Edge Width setting. This is basically a filter condition where if you have some noise in your detection where you want to filter out a width of a smaller size, you can set that here. Default set to 1, but so for example, if I set this to 10, it would eliminate any width measurement that was less than 10, for example. So it can be used to filter out some unwanted conditions there. The last step then is to just simply set up your judgment conditions, which is the pass-fail criteria of the tool. As you can see, we have the measured values displayed here, the minimum width and the maximum width. In this case, it's the perfect golden part, so the width min and width max are identical, but it depends on the part measurement. So what we're going to do is we could set tolerances accordingly. So if 60 pixels was our ideal part and we wanted to fail it if it got, let's say, 5 pixels bigger or 5 pixels smaller, we can set the limits accordingly. So what we'll do is for the minimum width measurement, we'll go ahead and set the low limit. So in our example, again, if we want 5 pixels, we'll set it to 55. So if any of the edge width measurements fall below 55, it will fail. And on the upper end, we'll set an upper limit on the maximum value. So again, we'll set this to 65. So if any of the widths that are measured go above 65, it will fail. Now, if that's all you want to set, you're ready to go. But if you want to go into the detailed judgment conditions, another setting that you can set is the detected segment condition here. So in other words, how many measurements are being taken. So in this case, you can see we're measuring 95 edge widths. So 95 of those segments have a valid edge width measurement. So if we want to detect a breakage, let's say there is a break in the part, where the width measurements were okay, but there's a break, we want to detect that, we can put a limit on the detected segments as well. So in this example, I'll go ahead and just put a lower limit of 95 on my detected segments. So if there's any breakage at all where we do not detect a width, it will also fail the part. Now, we've established our tolerance off the reference image, but while you're in the screen, if you want to work off of some of the current images, you can actually trigger on some parts and actually confirm measurements on actual parts, because the measured value will update on the current image. Also, up top here, as a default, it's kind of showing you a little help file here explaining the setting, but if you click this numeric icon, it will show you the numeric results of the tool as well here. So you can see in this example here, the maximum width has failed our limit, so it turned red and failed the tool. If I run through some more parts here, here's another example of a min width that is failed, and another min. And here's an example where we have a breakage in the part, so it failed the detected segments for that limit that we set. Now, by the way, the value that's displayed in green is the judge label. So if I go back up top here, the judge label is set for max as a default, but you can also set it for min, or you can actually specify a specific segment if you want. It doesn't affect the operation of the tool. It's still going to measure the min and max reading, but it's whatever that's the main target that you want displayed. So it just depends on how you want this tool to operate. So if we set it for min, for example, it will highlight the min point detected. So, but if we set it for max, and I'll show you this other example here, it'll show the max reading. So that's what that box in green is. It's the judged label. Click OK when you're done setting all the different parameters, and the tool is now complete. And you can also confirm the operation. While you're in run mode, there's a couple different views of this screen, as you can see here. One of the views is called Raw 2, and that's just the raw image displayed with the graphic. If you want to see all those yellow dots of the edge points, just change it to the filtered image, and it will display all the edge pairs for you if you want to see that. So that's just the filtered image. For our next example, we'll use the trend edge width tool to measure the diameter of a round part, like a washer. So what we're going to do is we're going to add the tool from the measured width subcategory of dimensions geometry and diameter. The first step with any tool setup will be to perform the image registration. What this will do is store what's called a reference image in the program settings, and you can use that to set up your tool. All you need to do is run some parts if need be, and once the image is on the screen, just simply click register. The next step then is to set up your inspection region of this tool. When you choose the Trend Edge Width tool from the Dimensions Geometry category and diameter, it's geared for circular type measurements, so your only choice will be ring or arc. In our example, we have this washer here, and we want to measure the min and max diameter around the whole part. So we'll go ahead and set up our ring centered around this part. So I'll set the inner ring inside the part, and then the outer ring outside the part, just enough so it can scan and look for edges. So what it'll do is when it detects the edges, it will look in between these rings. Just click OK once the region is set. The next step then is to set up the detection conditions for the tool. When you're using Trend Edge Width with a ring or arc, you have a couple extra modes here. One of them is called outer diameter. So what outer diameter will do is basically scan across the entire circle and give you the distance between the outer two most edges, and hence outer diameter. If you want the inner two most edges, you can change it to inner diameter. So what it'll do is, again, kind of scan across the entire ring and give you the distance between the inner two most edges that it finds here, as you can see here. Now the other two choices are outer gap and inner gap. So what outer gap is instead of scanning across the entire circle, it will just do a radius type scan radially, and it'll give you the distance between the outer two most edges detected in each little radius scan, if you will. So again, the outer two most edges, and what inner gap is the inner two most edges of the, again, radial scan here. Now in our example here, we only have two edges in an individual radius scan, so inner gap and outer gap are the same. But if we had multiple edges, like 4 edges for example, it would be the distance between the inner two most edges. So you select the mode according to the application. In this example, we're going to go ahead and put it on outer gap, so we want to measure the radially, just this outer gap of the part all the way around. So we want to make sure this width of the washer is consistent all the way around the circle. You can then set up all the edge detection conditions as necessary according to the application, like scan direction, edge direction, and sensitivity. Next, in the detection conditions, you could set the segment size and shift of the Trend Edge tool according to how you want this to be measured. You can see the default is 10 and 5, and in a ring or arc case, this is actually degrees, so it's like a 10-degree slice of pie here, if you will. And it shifts by 5 and does it again, and does it all the way around the circle. If you want to know how many segments you have, just simply click this numeric button here, and you can tell right now we have 72 segments and 72 detected segments. And a detected segment just means it has a valid measurement inside it. So if we want a little bit more detail, if we want to pick up on finer nicks and dings and things like that, or just finer detail of the part, we can set the shift and size smaller. So in this example, I'm going to go ahead and set the shift to 2 and the size to 5. So it's a 5-degree piece of pie, if you will. So you can see it's a little bit skinnier slice of pie, and it shifts by 2. So we got a lot more measurements here. But you can see it kind of just stops. It ends. That's the max segments. Right now it's set for 100, so it stopped once it received, reached 100. So what we'll do is we'll go ahead and set that up higher, maybe like 300, and you can see that encompasses the whole part. Again, we can click the numeric results up top here. You can see we have 180 total segments, and all 180 of them are measuring a diameter at this moment. The segment that's labeled here in green is what's known as the judge label. So that's the measurement that you see here, and that's also set right here. So as a default, it's set for max. So whatever the max detected width was across this whole region, it will kind of flag that in green. If you want to set that to min, you could set that to min, and it'll highlight where the minimum measurement was. Or you can actually specify a segment as well if you'd like. So if you want to scroll around and see the different segments, you can scroll through them. Where that could be handy is if you're having trouble finding edges in a certain particular area of a part. What you can do is move the segment number over to that area, and the edge graph will update according to whichever segment you have selected. We'll go ahead and set that back to max for this example. One last detection condition that's specific to Trend Edge Width tool, if you click the details here, it's called lower edge width, and this is just a minimum filter, if you will. So if I set this to 10, for example, what it'll do is if you say you had some noise or some unwanted areas where the width is real small you want to ignore, you could set this number accordingly. So in this example here, it will eliminate or ignore any width that's less than 10 pixels in size. To illustrate that lower edge width setting that I just set, I have a part here that has some small diameters, as you can see here, some more small gaps. So you can see it measures all the way around the entire circle, but when it reaches the width that falls below that 10, you can see they're ignored. So I just wanted to show you what that setting is doing. If you don't want that to occur, just to leave that setting the default, which was 1. So I'll go ahead and put that back to 1, and you can see we're getting the entire measurement there. The last step then is to set up your judgment conditions, and this is basically the pass-fail criteria of the tool. So we'll put some upper or lower limits on some of these values, and if the values fall outside that range, we can make the tool fail. We can work off the current image, trigger on parts if we want. You can see the currently displayed value here. So this measured value displayed will be whatever image you're working with here. So you can work off the current image, or we can change it back to reference image at any time. So what we'll do is we'll set our initial tolerance off the reference image, and then we can confirm with the actual parts. So what we want to do in this example here is for the minimum edge width, we want to set the lower limit. So if any of these measured values, the lowest one, if it falls lower than a certain value, we want it to fail. So in this example, we'll go ahead and set it for maybe 18. Again, these limits will depend on the actual parts that you're measuring. And what we'll do is we'll set an upper limit on the maximum value. So if any of these readings get too big, we want it to fail. And we'll go ahead and set that to 22, for example. And again, these values will just depend on the application, but in our example here, if any of those widths fall outside our measurement between 22 and 18, the part will fail. If you go into the detailed judgment conditions, you can also set a tolerance on the detected segments. And again, what that detected segments is how many valid measurements are taken. So in our target right here, our example, we have 180 total segments broken up for this trend edge width tool, and 180 of them are measuring a good reading or a good width. If I show you an example of a part that has a missing width, we have one here. You can see right here, it's failing because of the min here, so it's picking up some noise there, but you can see there's only 174 detected segments. So if we want to fail this part, for sure, if it has less than 180 valid measurements, we could put a low limit accordingly. So I'll go ahead and put 180 for that, so it'll fail that as well. So just in case, the width very well might be correct, but if we're missing some segments, we'll also fail it because of that criteria. You can also set a tolerance on the judge label, which we don't really need to. We've already set our limits on the edge width max and min, but the edge width is that judge label. Right now it's set for max, so it's set up the same. So you could also use that as a limit. But that's it. So click OK once you have set your limits, and then you can confirm the tool operation. You can see on the good parts, the values are in green for detected segments and max and min width. If any of the values fall outside the range, it'll turn red and fail the tool. You can also notice that we already have some position correction set up ahead of time, so the part will adjust according to the movement of the part. If you want to view the detected edge pairs or edge points, just change the image to filtered, and it will also show you the detected edge points. They're shown in yellow. One last example of the trend edge width tool is the peak-to-peak width, which is under the measure width dimensions geometry section here. This is the same exact tool. It's still the trend edge width tool, and it still does an outer and a max and min outer or inner diameter just like before, but what this will do is actually measure the outer two most edge points and the inner two most edge points of all the detected points as well. So that's the tool. I've already had it added, so just to show you, peak to peak, we'll edit here. I'm just going to show you the difference. The setup's still exactly the same as we just showed you. You set up your size, shift, and all the edge detections as necessary. But what it'll do is, of all these detected points on the left and all the detected points on the right, it will give you a total peak to peak max. So whatever the most furthest point out here is, and the furthest most point out here is, what's that distance, and then the inner two most points. So we call that peak to peak width. So in this example, it's a threaded plastic cap, so we can fail it if this total outside dimension is outside our range. You can see we put a limit here. So if I trigger on this next part, the width got too bad. So the tool itself is exactly the same. It just does an extra measurement. The max outer diameter and min outer diameter of all the detected points, not just each slice. If you go into the detailed judgment conditions, you can also set a tolerance or upper lower limit on the detected segments, the edge width max and the edge width min. So these are the traditional trend edge width max and min that I just showed you in the previous example. So you can still do the same things you did earlier. Again, it just does that extra peak-to-peak measurement as well. All the examples you have just seen are all examples of the trend edge width tool, as it's known as in the function list. The only difference between the dimensions geometry category is that it's optimized for certain conditions, as you'd seen, like round targets, linear, or that peak-to-peak measurement type. When you select it from the function list, you can freely choose rectangle or ring or arc right in the tool itself. And you set up all the other conditions the exact same way. And that peak-to-peak measurement in the third example you just saw me, all it is a toggle that you turn on and off. So if you want to perform that additional measurement that performs that outermost peak and innermost peak, you simply check the box. But the tool itself is the same. In summary, the trend edge width tool is a great tool to perform multiple edge width measurements across a part and pass and fail it if the dimensions get out of range. It can perform inner diameter or outer diameter, as you've seen in these examples.